Okay, we'll get started. Hello, everyone. Welcome to the Mediating Scale Conference, co-organized by myself and Oliver Kenny. My name is Magdalena Krysztoforska, and it is my great pleasure to be chairing this session, our final keynote presentation from Thomas Moynihan. Before we begin, some quick housekeeping. Please note that this session is being recorded. And please make sure to share any questions you have for our speaker using the Q&A feature, as we will have roughly half an hour for discussion at the end. Now, let me introduce our speaker, Thomas Moynihan. Thomas, are you here?
Yes, hello.
Okay, fantastic. Thomas is a historian of ideas and author of X-Risk, How Humanity Discovered Its Own Extinction, published by Urbanomic in 2020. Currently, he is a research fellow at the Forethought Foundation and a visiting research associate in history at Oxford University. He has written for the BBC, The New Scientist, The Guardian, among others. At present, he is working on a book exploring how history's horizons have expanded as the scope and severity of the consequences wrought by the present upon the future have ballooned throughout the past. And we're very honored to have Thomas sharing his new research with us today. And the title of his talk is Expanding History's Horizons, Bounding the Past, Sounding the Future, Gaining Orientation at Ionic Scale. Over to you, Thomas.
Thank you very much. And yeah, thank you so much, Magda and Ollie, for organising such a flawless and masterful conference. And it's a real honour to be speaking alongside all of the other speakers. The talks have been amazing. So thank you. And thank you everyone for being here. So yeah, let me share my screen. There we go. Great. So yeah, as mentioned, this is my kind of ongoing work for what is the next book project. Yeah, unfortunately there won't be any hamsters with hash browns in this presentation, unlike Bogner's, but there are some nice pictures of space. So yeah, without further ado. So today, I want to talk about and ask the question, where are we in history? And I want to talk about it in the broadest possible sense of the term. So where are we within history? Within the story of the human species as a whole, within the story of terrestrial life as a whole, perhaps even within wider ranges of nature's unfoldings. So full orientation in time in this sense, I think, involves the nesting of human timescales within nature's more encompassing scales, acknowledging that life and mind emerged from and can disappear within wider processes of autonomous nature. Full orientation also involves asking how much could be ahead, as much as establishing how much is behind. The ratios of future to past are practically important. Imagine you're on a hike and you are trying to orient yourself. You need to know how much is ahead as much as how much is behind. And I think that this is not in the business of making predictions about some X that will happen at future time T, but about seeking out upper bounds and boundary conditions within which all future events, whatever they turn out to be, must unfold. So it's not what will be ahead so much as what could be ahead. And so just to give a sense of what the current picture of contemporary science is, the universe is dated at something like 14 billion years, Earth 4 billion, complex life 500 million, Homo sapiens 300,000 or maybe 200,000, something in that vicinity. Civilization is only a handful of 1,000 years old, and technological science is less than a millennia. And so basically technological civilization is incredibly recent comparative to this whole sweep of the past. And now the future ahead is also capacious. So modern science predicts something like 500 million to maybe 1.5 billion further years ahead, within which complex life can survive and thrive on planet Earth. accidents aside. So sapient civilization, therefore, has only emerged very recently, but the future ahead, within which descendants could explore more of what is sapiently possible, carefully test out what is better, experiment with new ways of life, discover fairer institutions, and forge novel aesthetic achievements, could be voluminous. But we also now all accept that whether through folly, malice, or misfortune, the technological means now exist which could irreversibly scar or even permanently extinguish this capacious future, all within the span of the next few generations, which is nothing in geological time. Further, it is also now largely acknowledged that the scope of consequence for global catastrophe might be historically deep in some sufficiently weighty sense. That is, persistent, prolonged, possibly irreversible. Why? Well, because it is now widely accepted that Earth is likely unique in overwhelmingly large regions of space and time. The majority of the cosmos appears abiotic, both throughout its past and the observable present. But here on Earth, something historically novel and deeply historical has happened. Life has emerged and has taken hold. Yet, propagating and branching from this one common origin in cosmic time and cosmic space, all terrestrial life is therefore a product of its past in a profound sense. It is contingent and fragile because none of its species can effortlessly or spontaneously appear or reappear elsewhere or elsewhen in independence of this aeons deep legacy of events which needed to forge it. So, insofar as we now believe Earth species are unique to Earth, we must acknowledge that if some lineage is extinguished tomorrow, it is gone from the entirety of the universe from all subsequent moments forever after. Hence, extinction isn't merely a fact about the species it happens to, it is a historical fact about the whole cosmos within which it takes place. The scope of consequence for extinction casts a shadow throughout time and space, stretching as far as our sense of genuine, unrepeating history extends. So, to put all of that together, in the 21st century, the future ahead appears as capacious as it is precarious. There could be abundances of future generations and further development of life, or no future at all, possibly dependent upon what happens now. So today I want to explore how this orientation emerged. And the story I'm going to try and tell is how it emerged from steady expansions of history's horizon as modern science has pieced together the historicity of nature at greater and more encompassing scales. So to explain this idea of a horizon to history, what do I mean when I talk about a horizon of history? What I mean is that spatio-temporal arena within which people generally accept genuine history to take place. That arena within which practical concepts like impact or loss gain their bite because consequences and legacies can be indelible. So to unpack that further, what is genuine history? It is the time within which direction is irreducible because the past persistently limits future possibilities. Here, direction in time is irreducible because it is not eventually resolvable into some larger scale lack of direction due to eventual repetitions or limitless availability for the retracing of prior steps. So to kind of try and put this into a diagram, here's a diagram representing a fly moving around an environment, my desk. Each circle represents a state in which the fly can be, and the arrows represent transitions between states, and the numbers next to the arrows are the probability of that transition happening. You'll notice that the fly can, with a non-zero probability, get from any state to any other state. It will probably end up spending most of its time on the sandwich, given that the sandwich to sandwich transition is probably the most likely, but eventually it will always leave that state given enough time, and then it can reach any other state. They always remain available for it. So here, in this system, there is no genuine direction. The fly can always reach or return to any state from all the other states. It will eventually visit them all. Thereafter, it will eventually revisit them all, given enough time. This means that the present and the past can only constrain the fly's future movements in the nearer term. Eventually, all such constraints are overcome as the fly retraces and retraces again. Direction, therefore, is only local and transient because resolvable into wider directionless meanderings, wherein no potentials can be permanently lost or gained for the fly. In physics, such a system is called ergodic. So here's a second system in which a new state's been added, the flypaper. And you'll see that there's only one transition to the flypaper, and then afterwards, it can only transition from the flypaper to the flypaper with a probability of 1. So here, there is a genuine direction. Once on the flypaper, the fly can no longer reach any other state. It is in what is called an absorbing state. Here, there is a sharp before and after for the entire system, one that is not capable of being reversed or counteracted no matter how much future we give the system. RIP, Mr. Fly. Note, moreover, that the fly need not visit all the other possible states before entering this fatal state. You will also notice that extinction is an absorbing state for a species. So such a system is called non-ergodic. So to wrap all of that together, what is this genuine history? A system exhibits genuine history if it does not reliably visit all its possible states. Within such a system, time has a direction, because what can happen next is constrained not just by the present, but also by all that came before. Time is irreducible because past trajectories can influence the whole future, e.g. the flypaper in System 2. Within genuine histories, the trajectory of the past can therefore permanently canalize the possibilities of the future, opening up hitherto unexplored regions, closing off others, and making them impossible to return to. The system has a memory, its history matters. And so what is this opposed to? This is opposed to systems that, given enough time, reliably trace through all their possible states with a 0 probability of never returning to any one state, such as System 1. Note that such systems comfortably involve mutability, but never permanently or irreversibly. This is because it always remains possible to visit or return to any state from any other state. Such systems can retrace themselves without limit, such that their past cannot persistently canalize their future. Because of this, given enough time, any sense of direction or of the past limiting the future will eventually wash out into directionless meanderings. All trajectories through the system will eventually forget their extended past insofar as it ceases to define their present path. Let it run for long enough, zoom out far enough, the system exhibits no direction. Such systems are memoryless. And so, why does this abstract distinction matter? Where genuine history holds, contingency is meaningful and has practical bite because not all possibilities will be realized. Potentials can be lost, opportunities squandered, harms can be irrevocable. Actions can therefore inflict lasting impact on the whole system. Now, without genuine history, such practical concepts lose their edge because all possible states, good and bad, will eventually happen and happen again, regardless of what happens now. Therefore, actions can only inflict local, transient impact. So here, an important point to make is that it's easier to assume some system is ergodic than assume that it is non-ergodic. So this is because demonstrating an irreversibility is inductively hard. Proving something once was but never can be ever again is like proving a negative. Moreover, historical contingency is logically complex. It relies on articulation of possibilities that could have happened but simply never do. These are harder to apprehend and assess than possibilities we are familiar with through concrete precedent. Also, the larger the scale of a system in time and space, the easier it becomes to assume that it includes enough locales or moments for all possible states to be reliably expressed and re-expressed. The bigger the system, the more burden on evidence required to demonstrate its historicity. And perhaps most importantly and fundamentally, cyclicity accords with pre-theoretical experience of nature. The sun, the seasons, tides, and crops all eventually recede, but they also eventually renew, implying a wider level lack of direction. So, to synthesize all of this, the horizon of history. So it is what I define as the extent and limits of that spatio-temporal arena within which people broadly accept this genuine history to take place. That arena within which practical concepts like impact, consequence, achievement, and squandered opportunity gain their bite, and beyond which they are defanged by cycling returns, wherein everything achieved has already been achieved, and everything lost later regained. Beyond this horizon of directional process, directionless meandering insulates against genuine loss and gain, because all losses are eventually balanced by compensatory gains, and all gains eventually neutered by counterbalancing losses. So these horizons of history have shifted throughout history, and that's what I'm going to explore for the rest of the talk. My sense is that the further you go back in time, the more the commonly acknowledged horizon of history shrinks. For most of prehistory and history, for most people, I argue that it probably didn't extend far beyond one's own biography. Now, of course, other cultures throughout history have proposed extremely long temporal intervals. The best example is Hindu cosmology, where in the Kalpa, in the middle there, is the lifespan of creation at 4 billion years, which is eerily similar to science's current estimate of the age of the Earth. But nonetheless, these cosmologies, the Buddhist one as well, were often deeply cyclical, thus not clearly accommodating true irreversible historical change. However, zooming in on the West, two broad attitudes to cosmic time have dominated until very recently. These are the eternalistic and apocalyptic. Both have shallow historical horizons for various reasons. So to take the first, eternalism. So in eternalistic cosmologies, the past is big, so unboundedly big, that everything humanly achievable must have already been achieved innumerably many times. The future is so big, immeasurably so, such that everything now lost will later be inevitably regained or returned. So here, irreversible consequence may apply to one's own life story, but civilizations rise and fall and rise again, and wider nature goes on everlastingly in compensatory cycles. If I break my leg or arm, it is broken for the rest of my life, perhaps. However, people will be born to replace me lacking such injury. So here, I can point beyond the horizon of my own life to a wider spatio-temporal stage and claim that that loss is not truly permanent. Demonstrating this perfectly is Aristotle. He assumed that, quote, probably each art and science has often been developed as far as possible and has again perished, not once, nor twice, nor occasionally, but infinitely often. Within the multitude of years, everything has been found out, he argued. All possible achievements and discoveries are within the experience of the ages. And so he concluded that inquiry is thus attempting to supply defects in recall. Improvement is just returning to the peaks of the past. Plato assumed a similar thing. He argued that the past is of a long or infinite period of time, such that, quote, during that time, thousands upon thousands of peoples have existed, and by the same reckoning as many have been destroyed. Their social and political arrangements have been of every possible kind. Every possible permutation of moral and material betterment or decay has been passed through, unquote. If the past is infinite or immeasurable, then everything achievable will have been achieved before. Achievement is only returning to or reliving the peaks of this immeasurable past. Discovery is only rediscovery. So too with the future. Anything now lost will later be returned. So again, our actions have no persisting effect beyond our lives. They cannot cumulatively improve the world because over time the world contains an invariable amount of good or bad. On top of this, Plato also believed that catastrophes regularly destroyed its civilization, erasing accumulated human learning, thus putting an upward ceiling on achievement. Many others later followed this belief of recurrent civilizational resets. Cicero said that by reason of deluges and burnings of the earth, which must of necessity happen within a certain time, we cannot attain glory, not so much as durable for any long time, much less eternal. The arena of historical possibility was considered small enough that it would regularly exhaust itself and start again, without limit or cessation. So here is an attempt to diagram this horizon of history. So you can see the directional processes in the bottom within the horizon, stretching from the scale of the individual life, but ending beyond the scale of the nation or polis. And beyond that, you get this directionless meandering. And here, this was presumed to be on the scale of other civilizations and historical cycles. And so to move on to the second dominant attitude to time in the West, apocalypticism. So this arises obviously through monotheistic cosmologies with a belief that humanity, along with the whole entirety of the rest of the cosmos, is predetermined to simultaneously end as and when they were designed to. Although purporting a universal story stretching from time's beginning to time's end, Abrahamic cosmologies remain historically shallow regarding wider nature. Why is this? This is because mind and life are not subsumed within history's horizon as variables, as historical variables. Ethical agency does not emerge from, achieve novel things, and potentially disappear within wider nature. Instead, all regions of the cosmos are invariantly populated with moral beneficiaries and sufferers, angels and demons across all time and space. Ethical agency, in the form of God, orchestrates the entirety of natural history and dictates its arc. So because of this, there is no acknowledgement that nature has an autonomous history wherein vast regions in time and space can be unpopulated or abiotic. Whether through deity or directionlessness, a baseline of goodness or life is maintained from start to end. So the past and future were not boundless, but bounded by creation and apocalypse. However, the medievals thought that though local change might be able to be affected, the aggregate value or goodness of the whole was maintained by God and couldn't be meaningfully altered by humans. Here's St. Augustine arguing for this. He says, variable good was created and is governed alone by the immutable good. So it's a very ahistorical attitude. What's more, and probably far more importantly, historical horizons were even shallower in a stronger sense because most believers assumed they were much nearer history's end than its beginning. Most early Christians expected, even actively wanted the world to end in their lifetimes. Jesus said that the current generation would be the last. Cycling forward a millennia, Roger Bacon in the 13th century said, "It is believed by all the wise that we are not far from the times of the Antichrist, aka the end." Now, cycling forward a bit further to the 15th century, I think this chronicle beautifully illustrates this attitude to time. It's by Hartmann Schadel and it's called the Liber Chronicarum. It's like a roughly 300-page book that's meant to chronicle the entirety of time, past and future. Now, at the end of the book, Schadel left a number of blank pages for his readers to fill in the final segment of time, what was to happen next. And the amount of pages that he left, again, in a 300-page book, was only several, 6 in most copies. That gives you a sense of how much expectation on the future these people had. So this expectation that people were living nearer to history's end than its beginning persisted well into modernity. Here are a couple of notable examples, both by eminent scientific geniuses, John Napier and Isaac Newton. Napier predicted that the world would end in around 107 years in 1593. And Newton in 1704, based on biblical prophecy, predicted only 350 years of future. So what did this mean for people practically? This sentiment is really brilliantly encapsulated by Sir Thomas Browne in 1658. He said, quote, "We are living in the latter scene of time. 'Tis too late to be ambitious. The great mutations of the world are acted, or time may be too short for our designs. We whose generations are ordained in this setting part of time are necessitated to eye the remaining particle of futurity, and cannot excusably anticipate any future duration, which maketh pyramids pillars of snow, and all that's past a moment." Okay, so to move forwards into the scientific era and the influences and ramifications of science. From the 1600s onwards, geology began consolidating as a serious science. The geological record of superposed strata, each containing different fossils, a ledger of the past, obviously seems to imply direction and time. However, for a while, many resisted, trying to resolve building evidence of systemic direction into cycles of wider directionlessness and recurrence. Here's Benoit de Malet, a French thinker writing in the 1720s. He supposed that if we could dig down to the center of our globe, the remains of several superposed worlds, he said, entire cities, and everything we observe on the surface of the earth currently, bones of men and of animals and ruins and buildings, they'd all be down there. So this implies that it reduces the paleontological record to the archaeological, implies that there's no direction in the whole of fossil time. We'll just find the same stuff down to the bottom of the Earth. Similarly, Edmund Halley, also otherwise a prescient genius, assumed that Earth history had to be cyclical. Having theorized prehistoric cataclysms that wipe clean the surface of the world as an explanation for fossils, he wrote, "There may have been a preceding learned age, wherein possibly as many things may have been known as now, and perhaps many more." Similar to Aristotle's idea of civilizational cycles, but now cast into the fossil record. He concluded, even more bizarrely, that such civilization resetting catastrophes must be necessary for the well-being of the future world, even though this may be perhaps thought hard to destroy the whole human species for the benefit of those humanities that are to succeed. So this idea that somehow it rejuvenates the world by wiping it clean, a deeply teleological and cyclical view. But since around 1700, scientists have begun accumulating evidence of undeniable directionality in the past of the Earth system, in the shape of vestiges of a beginning for organic life. So as early as 1669, Nicholas Steno was noticing that some of the deeper strata contain no fossils. So he argued that these strata, which are free of all organic material, imply a period in Earth's past when animals and plants had not yet appeared. Moreover, people immediately started noticing that there was no sign of fossilized humans in the lower beds, no matter what de Mallet had previously argued. So on top of this, candidates for fossil humans were soon proven to be mistaken. So here is a picture of a fossilized newt that a scientist argued was the first fossilized human. So by putting a clear backward stop on life's history whilst also implying the recency of humanity within it, this meant that it became much more plausible to suggest that not everything humanly achievable has yet been achieved, here on Earth at least. Which, and I think this is under-acknowledged, was the requisite physical backdrop for emerging theories of social and material progress. Here's Marquis de Condorcet, the biggest cheerleader for progress from the century. He wrote, "The progress of civilization has no other limit than the duration of the globe upon which nature has placed us, and so long as there are no changes, as would no longer permit the human species to persevere." So, this was a new view. There could now be a direction to human history as an encompassing whole, emerging from some as yet unknown common origin, with determinate firsts and novelties lending an overarching shape, as opposed to directionless returns, amnesias, and resets throughout boundless time. Time had got a structure at the planetary level now. So contributions as well as damages to the whole human story, past and future, came into focus. Persisting ameliorations as well as indelible scars to that story became possible. So the question emerges, how long is left ahead? So moving to early scientific forecasts. The first quantitative estimate for future habitability, based on physical process rather than scriptural prophecy, that I've been able to find comes from Georges Buffon in the 1770s. He theorized that the Earth was created from molten matter ejected from the sun, and he thought that this internal budget of heat would eventually be expended by being dissipated, and therefore the Earth would freeze, killing all life. So a clear beginning, duration, and terminus. And so he conducted an experiment. He heated iron globes, then measured their cool-down times, and used rudimentary scaling to scale this up to the size of the planet to produce a forecast of how much heat expenditure is behind and how much might be ahead. He output 75,000 years for the age of the Earth and predicted that there would be 93,000 years of habitability left ahead. He did the same, interestingly, for all the other planets based on what he thought were their size. So, given that the Earth system had gained a definite beginning and a bounded past, and also that humanity's relative recency had been pinpointed within it, it could no longer be so easily assumed that everything achievable has already been achieved. Moreover, the planet also gained a bounded future, one that was to continue to grow in expected duration, yet would retain definitively an upper bound. So because of this, there could arise a sense in which determinately more or less could be understood as being prospectively achieved across that bounded future. There emerged a sense of time ahead, bounded yet capacious, within which novel things could be achieved. In other words, human actions in the present could gain a dimension of impactfulness, as inflicting meaningful alterations on the total amount of good or valuable things that will have been realized across the human story, set against the backdrop of the Earth system and its cohesive history. And so here, the horizon of history had radically grown. Consequence could now rudimentarily be thought of at planetary scale. So the horizon of history had circumscribed the planet as natural entity. However, people could, and did, point beyond our planet's horizon to the other planets of the solar system as arenas where life could continue and recur. Buffon himself said that it would be preposterous to depopulate the other planets, holding the then universally held assumption that each is necessarily inhabited by life and mind. So, because of this, it would take further subsumption of the domain of life within genuine history, and an expansion of its horizons to circumscribe the sun and the whole solar system itself, that would make such hopes for repetition or continuation on, say, Jupiter, Mars, Mercury, finally unbelievable, at least within our own solar system. So, subsuming species within Horizon's history. We're moving now to the mid-1800s. Before Darwin, it was not obvious that complex species absolutely could never emerge multiple times in disconnected places and times, divorced from shared descent. That is, in independence of the gradual accumulation over countless unbroken generations of countless adaptations. Now, what does that mean? Well, before Darwin, it was not clear that species are products of local history, propagating from a common origin in time and space, such that it was instead often assumed that they are somehow baked into the cosmos, independently of time and space, and are shared across all planets. Again, here's Benoit de Mallet arguing precisely this. He said, and this is again in the 1720s, he said, "Whatever may be the fate of this earth and its inhabitants, there are reason to believe that in the great multitude of globes contained in space, there will always be other terrestrial globes beside ours, which are inhabited by as many generations of men and animals. When species or civilizations disappear in one globe, they reappear in another. If a sun is extinguished, it is replaced by another. If a globe like ours is set on fire and all its living creatures destroyed, new generations will replace them on another globe." This assumption continued well into later modernity. Here's Hans Christian Ørsted in 1852. He's saying exactly the same thing. He says, "The same fundamental idea of the globe and of man must be repeated in each solar system." Many experts and biologists in the years before the origin of species assumed that complex species could and regularly had and did spontaneously emerge and appear divorced from any backward history or descent. So, assuming this, if lifeways do not require long winding histories to form, then the loss of any one species projects little historic consequence forward onto the future, as there's nothing obstructing something equivalent from effortlessly, readily returning. The depth and grooves of backward history required to produce a well-adapted lifeway needed to be revealed for the scope and range of forward consequence produced by its loss to be brought to light. Darwin's stress on lineal descent brought precisely this to light, it illuminated it. He said that complex species are never ever not the products of protracted histories, stretching back to common origins and relying upon unbroken propagation for their continuation. He was conclusive. "When a species has once disappeared from the face of the earth, we have reason to believe that the same identical form never reappears, for the link of generations has been broken." Darwin was never explicit about the further inference from this, but by tying species to their history and origin, Darwinism tethers species to their planet at birth. They will not be found again elsewhere. This throws into relief the truly cosmic scope of extinction. Though Darwin was never explicit about this, subsequent generations of evolutionists spelt it out. If lifeways are deeply, purely historical entities, they can also disappear irreversibly. So, to move on to subsuming the sun into history's horizon. And just to briefly recap here, early Christians seemingly expected the world to end in their lifetimes. Later Christians into the 1600s thought that they lived in the latter scene of time. But by the late 1700s, as science was growing, people were beginning to predict a natural physical future of maybe tens of thousands of years long. So what was the expectation in the 1800s? And this is where thermodynamics and the sun comes into play. In the later 1800s, physicists provide a first model for how the sun was formed and produces heat. They proposed a model of gravitational collapse. Vast quantities of diffuse matter, they thought, had clumped together into a ball, and by continuing to implode under the enormous weight, stars output heat as a byproduct. The new mathematics of thermodynamics was quickly used to estimate how long our sun had already been collapsing, as well as to forecast how many years of sunlight might be left ahead. So the first rough prediction for the future lifespan of the sun was produced by William Thomson, later Lord Kelvin, in 1854, and he output a number of 300,000 years of future for the entire solar system. By the end of the 1800s, physicists converge on very low tens of millions for Earth's habitable future. Hermann von Helmholtz in 1871 predicted 17 million years. Charles Augustus Young, a decade later, says something like 10 million. So here, the future of the whole solar system had become large but determinately bounded. It had been subsumed into the horizon of history. So now people had to point beyond to other stars for any sense of recurrence or recommencement. So at the same time as thermodynamics was accomplishing this, it also taught that all energy on Earth comes from the sun's irrevocably dissipating fund. This was a fund that was enormous yet definitively finite, such that it could be plausibly squandered. And since industrial growth at the time was premised entirely on coal, which of course is fossilized sunlight, and thus an enormous yet finite fund, some, from the 1860s onward, suggested that extravagant and wasteful expenditure of coal in the present was potentially inflicting harm on far future generations. So here, for the first time, was understood a way in which the whole terrestrial future could be impacted, for good or bad, in tangible ways that were seemingly irreversible and contingent. The horizon of meaningful impact had extended far into Earth and humanity's future. Again, to sum up, this sense of the future, the effectable future, the impactable future, had grown steadily. So early Christians, something like a lifetime, Isaac Newton, 350 years, Buffon's 90,000 years, by the mid-1800s, something like 300,000, and by the close of the 1800s, something on the order of 10 or tens of millions of years. And so some forward thinkers were identifying safeguarding the growing future as of ethical interest, but there remain some limiting reasons why it couldn't yet become a major concern. So these forecasts of 10 million years were admittedly much larger than Buffon's earlier estimates. However, in the century since Buffon, the sense of life's unexplored potentials had grown. Now, this was in part due to Darwinism. Moreover, the gravitational collapse theory of the sun's heat production led physicists to conclude that the ratio of past spent to future ahead was somewhat unforgiving. Robert S. Ball in 1892 wrote, "It seems that the sun has already dissipated about 4/5 of the energy with which it may have been originally endowed." What proved especially depressing was the idea that evolution had come thus far, this grand sweep of lineal descent, but didn't have the time to go much further. A journalist in 1893 responded by saying, "All the aeons spent bringing us up to the present point, and no sufficient time remains to evolve all the possibilities of our actual state. This is sad indeed. Waste, sheer waste on the most gigantic scale." So, as the 1800s closed, there was a belief that we were living in a dying world, past its peak, and that there wasn't the time, energy, or available fuel to see much more development. A freezing senile death awaited that distant future. But then, in around 1900, radioactivity was discovered by pure luck and surprise. So, having coined the word radioactivity, Marie Curie successfully isolates radium in 1902. Discovery of radioactivity reveals a titanic, previously completely unacknowledged wealth of energy is locked up in mundane matter. So in 1903, William Crookes estimated that 1 gram of radium, if it was caused to decay, would be enough to blow up the whole British Navy. Immediately, the wider public fall in love with this idea, and it creates radiomania. Moreover, given the extreme length of decay rates, it also provided the first reliable way of accurately measuring physical processes, past and future, stretching into the many billions of years. So people immediately realized that things like thorium and uranium, their decay rates extend into the billions. So because of all this, timescales couldn't help but expand. Here's a nice illustration of this. This is a radium clock powered by one single tiny speck of radium that was calculated to run to 20,000 years. So rather than decrepit, the world suddenly seemed youthful. Immediately, scientists start postulating that radioactive power somehow fuels the stars. Rather than languidly collapsing on itself, the sun now seemed like a self-heating furnace. Almost overnight, this massively expanded physicists' estimates on upper bounds for solar lifespan, and therefore also the effectable future habitability of Earth. George Darwin, in 1903, a relation of Charles, argued, "Perhaps the sun is liberating atomic energy. Accordingly, I see no reason for not augmenting the estimate of future solar heat by some such factor as 10 or 20. So, an extended and extending future. The expected future, as I mentioned, explodes overnight. So the Daily Mail in 1903 writes, Lord Kelvin in his most desponding moments only assigned a beggarly 5 or 6 million years to the future duration of the life-giving sun. But here comes radium to the rescue. It lengthens our species' expectation of life by several hundred million years. Similarly, Harper's Magazine, a few years later, wrote, the discovery of this new form of energy has extended indefinitely the backward and forward sweep of the cosmical timetable. And so by 1920, Arthur Eddington, aside from Einstein, probably the biggest physical authority, was predicting 15 billion years of future habitability on Earth. Being even more bullish, James Jeans, by the end of the 1920s, was predicting 1 trillion future years, which turns out to be wrong by an order of magnitude, but nonetheless shows how much time horizons were expanding. And so because of all this, the effectable, impactable future had also grown, and so people's sense of responsibility had in correlative accord. Here's the brilliant American geologist Thomas Crowder Chamberlain in 1903. He wrote, we have grown up in the belief that the Earth sprung from chaos at the opening of our era and is plunging on to catastrophe or to a final winter in the near future. Quite at variance with this, we now know that the Earth offers a fair prospect of fitness for habitation for ages yet to come. If this be true, it is eminently fitting that humanity should give a due measure of thought to the ulterior effects of its actions. A vast future of habitability may fairly be predicted. Whether you are prepared to accept so large a view of the habitable future or not, I trust you will strike hands with me in the conviction that the probabilities of the future are at least so great as to render imperative the serious consideration of our obligations towards it. Now, Chamberlain was amongst the first in the history of science to realize that anthropogenic climate change was possible due to burning of fossil fuels. And so he and a few others at the time realized that through perturbing the climate in this way or recklessly expending non-renewable resources, we could ruin or even somehow extinguish that entire prolonged, capacious future. He wrote in 1910, Earth may be congenial to life for tens of millions of years yet to come. The congeniality of conditions does not ensure actual realization. Protracted habitability does not necessarily carry the actual realization of the future opportunities thus open to our species. So again, a deeply contingent and therefore non-ergodic idea of this expanded future. So, final section now. This is the final expansion that I've thus far identified. And so yeah, this section is called Making History Cosmic, Making Cosmic History. So, say if through cosmic collision or suicidal folly, life on Earth were exterminated tomorrow, surely similar histories would be going on, retracing similar steps, similar glories and follies in nearby stellar systems. This is the final beyond of history, the sidereal expanse, assumed at the beginning of the 1900s to be measureless and eternal. So, for an infinite or eternal cosmos, life must always somewhere exist. Indeed, all histories and historical alternatives must always concurrently exist if the universe be eternal or infinite. So this is a kind of ergodicity of the gaps, a recession of this space of recurrence and cyclicity. And yeah, towards the turn of the 1900s, people were arguing for these things. Here's Auguste Blanqui in 1871. I probably absolutely butchered that French pronunciation. And he was actually an inspiration on Nietzsche's Eternal Return. He argued that because space was eternal and infinite, not just other inhabited worlds, but the history of our Earth and all of its alternatives are all concurrently going on, and therefore so are all our life histories, everything. And so he said that the starry expanses are the future regions of our immortality. The number of our body doubles is infinite in time and space. So, by the opening of the 1900s, cyclicity had ceded much ground to historicity throughout nature. People were now having to point to other star systems, other galaxies, other island nebula for this idea of recurrence. Now, that was speculative philosophy. Scientists, on the other hand, were a bit more cautious, a bit less extreme, but they still maintained one final bastion of eternity, life itself. That is, they continued to steadfastly maintain that life in the cosmos is not historical, having never properly originated anywhere or anywhen, such that it can also never properly end. So this took the form of the theory of panspermia, popular during the decade straddling 1900, which argued that life doesn't originate or emerge from unliving matter, but simply circulates unendingly from planet to planet. August Weismann, in the 1880s, spelt out the conclusions of this. The idea that life can only arise from life, and has always so arisen, entails organic beings are eternal, like matter itself. So that which lacks or doesn't require a true origin is also imperishable, somehow existing, at least latently, everywhere or everywhen. Such a theory, of course, meant that, on average and over time, the amount of life in the eternal cosmos will remain invariant. Svante Arrhenius in 1907, also a pioneer of climate change, he was very strongly a believer in panspermia and probably the most extreme proponent of it. He argued that circulation of life from planet to planet has neither beginning nor end, and life may exist and continue forever and undiminished. This, of course, meant that all life, no matter its planetary home, is in some sense related. So through this, scientists continue to cling to a remaining sense of escape from the terminus of the grave, and could retain this idea of eternal, unending progeniture insulated from all risk. So Arrhenius again argued, finally, we perceive that, according to this version of the theory of panspermia, all organic beings in the whole universe should be related to one another, and will develop and have developed along lines which are closely related to those of ours on Earth. Similarly, Helmholtz, also a believer in panspermia, he said, who knows whether meteorites do not scatter germs of life wherever there is a new world, which has become capable of giving a dwelling place to organic bodies. And this life we might perhaps consider as allied to ours, related to ours in its primitive germ. So, Earth species might now be historically variable in some cosmic sense, but life is not. But then, in the 1920s and 30s, observational and theoretical evidence builds that the universe is actually expanding. The galaxies were noticed as receding away from us and accelerating in their recession. So extrapolating backwards, this implied a time zero, a beginning, what Georges Lemaitre called the primeval atom. So where previous physics had broadly, almost unanimously assumed a steady state eternal cosmos, now the entire universe was appearing to be gaining a history. And so at the beginning of the 1940s, George Gamow, brilliant physicist, argues, quote, not so long ago, one of the favorite explanations of the appearance of life on our planet was the panspermia hypothesis. But this becomes rather senseless in the light of modern knowledge concerning the age and origin of the stellar universe. It now seems rather certain that the stars themselves are not eternal and were born. This physical creation of the universe must have taken place during the epoch preceding the formation of our Earth and other planetary systems, and since it is obvious that at that time no life could exist anywhere in the universe, the problem of origin has to be faced anew. So panspermia was knocked off the knocked down the plausibility charts by this idea of the Big Bang. But what of the intentional rather than natural and autonomous spreading of life? Near the very beginning of the space age, people started asking such questions. Here's de Chardin in 1945. He said, "If journeying between celestial bodies were practicable, it is hard to see why we ourselves have not already been evaded." Many people in the beginning of the 1900s said similar things. They said, if the universe is in some sense eternal, then and if space travel is possible, then we must have already been invaded from without. So we can reason from that space travel must be in some sense impossible. This was a common argument. However, as soon as the universe gained a tangible finite past in the history, it became at least plausible that such spreading is possible, but simply just hasn't happened yet. Putting a stop on infinite past time, as always throughout the whole rest of this story, emancipates future possibilities and novelties. In 1950s, the anthropologist Lauren Isley saw this clearly. He argued, after the discovery of galactic recession, infinite time is not at our disposal in estimating life's capacities. But if such feats are even minimally possible, why haven't they already happened in the enormously finite past? Why are the older aliens not already here? This is, of course, the context for the Fermi question. You need a historical cosmos in which to ask such a thing, because in an eternal one, the spreading would have already happened if possible. So in 1950, Enrico Fermi asks the question, where is everybody? Back to Isley. In 1957, he wrote, "Since we now talk endlessly of space rockets, it is no surprise that this thinking yields the obverse of the coin, that the rocket or its equivalent may have come first to us from somewhere outside. Surely, in the infinite wastes of time, in the lapse of suns and the wane of systems, the passage, if it were possible, would have been achieved. But the bright projectile has not yet been found. But the present theory of the expanding universe has made time as we know it no longer infinite. If the entire universe was created in a single explosive instant a few billion years ago, there has not been a sufficient period for all things to occur, even behind the star shoals of the outer galaxies. In the light of this fact, it is now just conceivable that there may be nowhere in space a mind superior to our own." A few years later, Penzias and Wilson discover the cosmic microwave background radiation, pretty much confirming the Big Bang theory, and therefore also this suggestion that in the observable cosmos, life must have had a beginning somewhere and somewhen, such that we cannot assume that it has accomplished everything it can achieve. And then after that, since the 1960s, scientists have begun searching the skies for signs of other histories unfolding and perhaps spilling outward. As we know, they have found nothing conclusive. "We live in a psychozoic vacuum," as Stanislav Lem once said. This leaves two obvious options. Either Earth is the first seedling, encumbered with gigantic potential, but equally fragile. Or there have been many previous attempts and all have failed. Both are troubling for obvious reasons. And so to wrap all of this up, because of history's expanding horizons, it finally becomes plausible to propose that this universe could potentially house abundantly more life, but simply it presently does not. Possible, yet not yet actualized. From this, one can then look upon intelligence and see it as a kind of primary nucleation of crystal from a solution. A primary seed, minuscule and fragile at first, but charged with the potential to tip the entire system into a dramatically new state. Perhaps mind might be the catalyst, the spark plug that triggers the shift from an abiotic to a biotic universe. Who knows? Perhaps this is nonsense, but such options are now firmly on the table, whereas they weren't even 60, 70 years ago. Regardless, if the biosphere is destroyed now or we somehow ruin it ourselves, I think the prospective consequences might be comparable to imagining what would have happened had the first fragile germ of life on Earth billions of years ago been extinguished before it could take hold. Plausibly, the whole grandiose sweep of earthly evolution might then have never happened. Us humans are a tiny and radically contingent product of that grand stream of life. It has traced a deep past already, but it might yet have a wildly more capacious future. Our species might turn out to have been a transient or useless part, or we might turn out to have been an instrumental and important part in spilling life into environments otherwise unreachable. But whatever we turn out to be, we had better not become the part which stops this awe-inspiring stream in its tracks, foreclosing everything it might have gone on to become. And so, as a final thought, whatever happens, I think it's true that by making history cosmic, it provides at least the possibility of believing that we could all be making cosmic history, however infinitesimally we're doing things that somehow alter the stream of time irrevocably. JBS Haldane, abreast of the biologist, but deeply abreast of the developments in physics at the time, wrote in 1945, "Believing the universe has a genuine history provides no strong grounds for hoping that the world will be a better place a million, let alone 1,000 years hence than it is today. However, if the universe has a real history, not a series of cycles of evolution, then it is possible that life could not have started much before it did, nor have got much further than it has at present. If this is so, human effort is worthwhile, and human life has meaning." That's a sentiment that I deeply agree with. And so as the final closing thought, history edifies and orients, whereas eternity stultifies and intoxicates. And so that's why I love history. Yeah, so just to finish, this is my attempt to put the whole of the talk in a diagram. So yeah, this expansion of the acknowledged kind of forward horizon from the individual to the nation, then to the whole of human history, this resting on the development of geology and paleontology. So this is, sometime in, say, the 1700s onwards. Evolutionary history, then, the idea that species are deeply historical entities, emerging from one place in time and propagating forwards, such that if they're disappeared forever. That's obviously based on Darwinism in the mid-1800s. Then the expansion of history to include the whole solar system, that happens based on thermodynamics, some point in the mid-1800s as well. And then finally, this expansion of history to include the whole universe, which, this is based on Big Bang cosmology beginning in the 1920s, confirmed in sometime around 1960. This is all super abstract and like really high level stuff that who cares if we live in a historical universe or not. True, I don't think about it when I get out of bed, but the fact that time is irrevocable does have these profound consequences. And so I hope that I've perhaps illuminated some of them today. So thank you.
Thank you so much, Thomas. That was incredible. Thank you so much. It's been such a rich talk. I'm definitely gonna rewatch it and try to take more in. And everyone in the audience, please write your questions in the Q&A box. You can see there are already some questions. But I'll also happily get started with one that I think also the reason why I was incredibly happy that you accepted our invitation to speak at this conference is that I think there is, especially in media studies, when we think about mediation and thinking about audiovisual media and the artifacts, and even though, as Zachary Horton also pointed out on day one, that we are obsessed with scale and we think about scale all the time, and it is now more and more on our radar that there's different scale and a lot of problems are large scale. But I think that we are sometimes, even though we are quite critically very often analyzing the representations and maybe the visual representations of that, I think that your work, this way of looking at through the history of ideas and trying to trace the lineage, it's also, in a way, our understanding of how ideas develop is also the way our understanding of scale is mediated. If I'm not representing your work, and I was wondering whether there's so many different kind of ways into thinking about mediating scale through what you mentioned in your talks, this, of course, the science and the different spatial directions digging into the ground and thinking about the cosmos. But I also, I would really like you to talk about this idea of history, also history not in terms of time, but also history of ideas and intellectual history, and how understanding how those ideas came about, how they developed, is actually a great lens for us to also understand scale.
Yeah. So I think, there's a lot there. So I think that, that it's very easy to assume, and there is a lot of truth to it, but it's very easy to assume that like humans have always had a sense of the utterly gigantic and the mesoscale, and then the small. But how far those go has shifted dramatically in time. And if there's one insight that I could like communicate to the world, I would want it to be the idea that there is a massive distinction between assuming something is infinitely large or eternally, temporally distributed, and just thinking that it's finitely enormous. And that I'm very confident that it's a crisp, novel discovery of modern science to realize that the history of, the histories of nature, aside from being kind of places within which human history and life history emerges and can disappear, like, that's something that I think is so unobvious to the intuitive manifest image that I would be very surprised to find it anywhere else before, kind of modern science in the history of ideas. But yeah, like it's this, the story of modern science is basically like revealing finite enormities in time and space, and then those are things that we can orient ourselves within. So it seems that like there are two very deeply attractive things for like, let's talk about the manifest image. One of them is to assume, that there's like not that much time ahead and not that much time past, like these I was talking about like Christian biblical predictions on the future as being like a handful of generations maybe, but as we all know, their predictions of how old the world was were like also paltry as hell, like 6,000 years. And so there's this one pole is like, time is short, time is small. But then the other pole is to just go, oh, it's eternal, it's measurelessness, and those two things, like, you can't gain an orientation in them. So yeah, it's what science has done is revealed these enormous finitudes, and you need a finitude or a bound to orient yourself. I mean, Kant says this, right? But like, this is far more like concrete than anything he was talking about, but it's a similar insight. And so, I guess on the mediation point, what I find interesting, I didn't touch upon it at all in the talk, is ways of mediating this sense of finite enormity, because it clearly is like psychologically difficult for us to arrive at, the fact that it took modern science to like wring it out of our brains. And so there's a challenge there. The challenge is like, if we swing between these poles of like, tiny time and measureless time, how do we like get across the idea that like, 14 billion is meaningfully different than an eternity, when most of the time we just see 14 billion and are like, we're so staggered that we're like, wow, that's basically infinite. And you see so many people saying this across this kind of particular history that I've kind of been digging into. People saying, oh, that's basically infinite. Like, who cares about a billion here and there? It's, it's all eternal. And so there's a question of like mediating that to people and making it tangible. And it's quite hard. Visualizations are like the best way. So, we're really familiar with that time spiral that shows the different nested kind of stories next to each other of like life, history of Earth, history of cosmos. That's a really non-obvious way of visualizing time. But there was also a time before which people understood bar graphs. So like, there's in the same way that evolution, is historical because it doesn't realize all its possibilities. Like there's clearly way more possibilities for visualization and mediating these scales ahead. And that's something I'm interested in, is like, how many more diagrams can we, like, there must be so many out there that we haven't yet realized. So yeah, I that's, some thoughts and responses. I'm not sure if that like answers the question, but regardless.
Yeah, it's perfect. Thank you. I have lots more questions from as well, but I see there's a lot from our audience. So I'll read them out, but you can also see them in the Q&A box. So Piotr Szpunar is asking, I really enjoyed the genealogy of the temporal expansion of the future. I wonder how you might fit it into this history. Two things that come to mind: the role of extinguishing extinctions without which we would not exist, and the various contemporary musings about the end of the universe in theoretical physics, heat death, the big crunch, the big rip, etc.
Yeah, that's fantastic question. That's like hit some of the nails of what I really find interesting on the head. So yeah, thank you. So on number one, if I'm reading that right, role of extinctions without which we would not exist, which is a fascinating thought and kind of shockingly late, as I'm aware, in the history of evolutionary thought. And yeah, this is like a really salient counterfactual, is the idea that if you went back and knocked out any single line of the continuous thread that goes from us all the way back to the beginning of life, but that's probably a bit too expansive. Like, any of our ancestors on the mammal branch, nothing like humanity would have ever existed. It was like really late that people started realizing that that was a consequence of evolutionary theory. So Darwin himself was like deeply adaptationist, which means that he thought the major mechanism of speciation and extinction and variation was basically based on having bad or good genes, and there was therefore no room for bad or good luck. So that lends itself to this quite progressivist reading of evolution, which Darwin himself fell foul of quite often, which is that replay it as many times as you like, and adaptation will just push animals towards more complexity. Because we're self-serving creatures, we equate complexity with encephalization and bipedalism, etc. So there was this sense that like extinct animals of the past that died were like unsuccessful experiments of nature. You find people saying this well into the 50s and 60s. And then it's basically with the like Alvarez hypothesis that the dinosaurs died due to bad luck rather than being bad genes. Like the stuff that people used to say about dinosaurs before the 1980s is just like downright like rude. Like they're like, oh, they died because they were decadent, they were lazy, they were stupid. It's only after the 1980s that you're like, okay, this whole like family, like this clade of like animals that was massively dominant and successful and well adapted was wiped out, not because of bad genes, but because of bad luck. And that throws into relief this really salient counterfactual of like, okay, if that hadn't happened, then like, would humanity be around? Like probably not. You see the afterlife of this idea and the assumption that dinosaurs would have eventually evolved into kind of bipedal, like intelligent beings, which, is nonsense. Stanislav Lem actually has a very good argument for why that's nonsense. But yeah, so that is part of this story of like realizing the depth of the contingency of the Darwinian hypothesis took a long time to be revealed, and that's based on like the stubbornness and the inertia of lots of like Western assumptions about progress and the inevitability of progress. So the kind of what I'm calling this extension of the horizon is basically the extension of contingency and like our awareness of all the unrealized possibilities that like surround actuality as a halo of like what makes it genuinely historical, right? Is what would have otherwise happened. And so, yeah, it took a long time for this to come to the fore, which I find interesting. I'm going on now, but yeah, on the various contemporary musings about the end of the universe. It's what I just find interesting is that the level at which we now have to point to say that's where the kind of recurrence and the eternal return happens is now expanded to like the most theoretical like dimensions of physics, where it's like, like quantum stuff, like, the kind of branches, modal realism also fulfills a similar role, and like oscillating universe ideas like, the big crunch and like similar like kind of cyclical ideas that there's a crunch and then another bang. Like now it's so speculative. Like now it's so far beyond. Like whereas only like over 100 years ago, people could go, oh, the next star system will have humans and civilizations doing good things in it. So now we're having to point to the multiverse. So I think there's something important there. Yeah.
Thank you. Lawrence Kent also has a question. He says, brilliant. Could you speak more of the meaning in your formation of meaningful future change that humanity discovers? Is such meaning only possible in non-ergodic space? Is this a question of the scalability of meaning?
That's a great question.
Perfect.
Wow. Okay. So, well, I feel that for something to be meaningful, it has to be, it does have to be connected to irreversibility in some sense. So if it, like, a good thing about having an argument with a friend is that it's reversible because you can forgive and make up for it. But like, I use the example of like breaking your leg, like, depending on how severe it is, that can be an irreversible thing. And I think that like, yeah, like that is just like, it's so deeply intuitive to me that that is part of what makes something practically meaningful. Now, and this connects, I think, into the next question. Maybe is is this necessarily a consequentialist like ethic? The interesting thing is like the kind of German idealist, like big deontological kind of fathers of that idea of ethics, like also cared about these things as well. Like there are places where Kant is like, it would be really bad if humanity died tomorrow before it does all the things that it could do. So I think that it's like, I don't know, unrealized possibilities. There's something sad about them. Like, it gets really difficult because say that you want to realize as much diversity, let's talk about ecological diversity. Like if you want to realize as much ecological diversity as possible, that means that you're going to necessarily be realizing like many parasites and diseases. So, it's very hard, but yeah, I do think it is a question of the scalability of meaning in the sense of, legacy, impact, consequence, and also continuation as well. Like, I think that there's something like profoundly, I don't know what the right word would be, but there's something like worldview shaking about realizing that there is a continuous stream of generations going back from me and everyone like currently alive to the very beginning of life. So I think that there are other ways of thinking about this. You can think that there's a dignity just to the kind of the continuing diversification of species, and the fact that they are deeply historical lens. I mean, Darwin himself, he used the word ennobled. He said that I think that it ennobles species to think of them as like the lineal descendants of the first forms of life, rather than just something that was plopped onto creation at the end. And I agree with that. So yeah, I think that seeing ourselves as part of this huge tradition, this great stream of life going back to the beginning, I find that really meaningful. And yeah, I don't know how else to express it really.
Yeah, so that's so I hope that in some part addresses Yazdan's question as well. He asks specifically about how people thought about ethics, but I think that links nicely as well.
Yeah. So I mean, that's a fantastic question. So I think that yes, definitely. So Aristotle's like ethics, ariteological, I think is what you call it. I'm not sure if I'm pronouncing that right, but kind of virtue ethics, right? Like, is deeply colored by his attitude to time. It's totally informed by it. This idea that because of his sense of possibility as not extending beyond what is actual in any meaningful way, you know, because of his ergodic sense of time and history, there couldn't be an idea of optimality. So the idea that like what is good is finding the best thing in a possibility space, and it might not have already been realized. So what virtue ethics basically teaches is, aside from the golden mean, which is kind of the opposite of optimality or like perfectionism, it basically teaches, you know, be the best person based on the precedent of what the best people have already been. So you're kind of returning to the peaks of like virtue that have already been kind of navigated. There's no sense of optimization beyond that. And so it's the expansion of possibility over actuality that happens kind of steadily throughout the medieval epoch and then explodes in modernity, that creates this sense of optimality or perfection. You know, perfection being something that hasn't already been realized. And so, yeah, I think that the birth of like the two modern systems of ethics, like deontology and consequentialism, is based on this kind of sense that like value or goodness or whatever you want to call it as a cosmic whole is no longer invariant. Like it's actually variable in time. And so regardless of whether you think of it as a duty, that your duty is to be, you know, the fullest possible sense of what it is to be an intellect, which is kind of Kant's version, or the kind of consequentialist idea of like affecting total aggregate goods that all have been realized in the cosmos. They both rest in this idea that like across time value is variable. And so I think that that's like a fundamental shift. Obviously this is like high level and like who knows, you know, it's kind of so high level that it's like quite shaky and like I'm sure could be knocked down, but I think that there is like at least a kernel of truth to it. Yeah.
Absolutely. I was wondering also, you started your talk, I made quick notes, so correct me if this is incorrect, but I thought you said the ratios of future to past are important, the technological means exist, and scope of consequence for catastrophe is deep. So I wanted to also thinking about the current moment, like the way you pick out those kind of rupturing points in history where there was the shift of horizon and the shift of understanding of timescales and futures. I was also wondering, the technological means exist. I also wanted to ask you about those points right now that you think maybe we're not addressing enough and should be addressing. I guess what I'm also trying to do is to I see so many connections with our previous keynotes as well. And I think like we've been so far in this conference focusing a lot on the specific technologies and thinking in terms of technology and agency in this way in terms of technological apparatus and how we're using it. And I was wondering whether you could talk about the present moment and where you see those points that maybe in the future, writing intellectual history of the now would be those points that you would be definitely including.
Yeah, so I guess like the pantheon of like, you know, globally destructive things. I mean, the one that I find most worrying on a daily basis, maybe not a rational one, is like, and it isn't just based on the fact that it's like become far more salient in the past like 6 months for obvious reasons, but is like, you know, the amount of nuclear weapons in the world, like that you know, like let's start with like tangible non-speculative things, like nukes already exist, like that, and there's like tons of them still. So yeah, you know, in terms of like how that connects into this history, it's really interesting. Well, so you know, people talk about kind of the current era of precarity, like dating to like, you know, the first nuclear test. You know, it was like the development of hydrogen bombs in the early 1950s is probably more of a like shift in destructive force because they are theoretically like unbounded in how big they can be. So like Edward Teller like had this thing where he was like, you know, I can make them theoretically as large as, like, there's no upper limit to them, but like at some point it becomes a waste of energy because most of the energy will just be like you know, directed outside of the atmosphere, and so you get that. then it's not really clear that there'd be a clear causal mechanism that could destroy the whole of humanity based on nukes. It could just like irreversibly wreck the like entire future. That's not entirely clear. There's, you know, fallout. Like there is an idea that that could destroy ecosystems, and then there's this idea that turned out to be false, that you know, nuclear explosions would destroy the ozone layer. But it's interestingly linked with this, the Alvarez hypothesis of the asteroid killing the dinosaurs, is the causal mechanism that was argued for that was an impact winter. And some of like, I think it was actually some of the same like models we used to like simulate the impact winter from the KT event, as were also used, or at least informed, the simulations of like how a nuclear winter would pan out. And so, you know, this is like Sagan and co. I think like, yeah, it was like in around the same time as the Alvarez hypothesis in the 1980s. So you get this idea that like, okay, wow, like the biosphere is like, you know, we could actually like, you know, not just like perturb it in a large way, but like irreversibly scar it. And yeah, like the depth of historical consequence for mass extinctions only really becomes like the topic of like concerted study after that. So like there's a bunch of biologists like David Raup, Stephen Jay Gould, who after the 1980s go, oh wow, like the Earth system's like deeply complicated, and mass extinctions are like, you know, the most significant events in its past. Yeah, and more recently, like there's this idea that there wasn't an idea that once you have mass extinction, life like bounces back and like rebounds and rediversifies because there's like open niches. But I think evidence more recently has pointed to the fact that to have those niches, you have to have all the species underneath that support them. So this is like this idea of ecospace, like has to be structured. Like you don't just get it for free. So like there are actually like we could like mass extinctions actually seem to scar the biosphere, and it takes a very long time for them to recover. So again, this is just this expansion of like how, you know, how historical things are, like, you know, just having some sense of like history being this like grand upsurge that is, you know, inevitable is like such a like shallow idea of history. And that's the one that we're all like kind of inherit in the West as like the idea, like, you know, the kind of grand Victorian Darwinian march, but like it's actually like a branching bush of like countless possibilities, and some of them are awful, some of them might be quite good, and you know, it's our job to like try and navigate through. So yeah, yeah, I'm not sure if that does answer that, but yeah, at least some reflections.
Thank you so much. I guess I feel like I'm asking very simple questions. Your talk was so rich that I feel like I want to ask so many detailed questions, and they all just kind of amount to this very, very general statements. But I also urge everyone to read Thomas's book, which is incredibly rich and detailed as well. But I wanted maybe finally, it's a kind of question that keeps coming back throughout this conference, and that I think is also the way I see it is like a driving force in your work as well, is this question of agency, that mediation of scale and how it's mediated also changes this position of where we assign agency. That's also what Bogna talked about as well, and talking about Lem's work as well, and how the human relationship with technology and where the agency is. And I wonder, again, from your very unique perspective, looking at those timescales and those shifting horizons of possibility and of history and of the future, how we reframe, or maybe how we should orient a human agency, because of course there are those perspectives where we can think that, okay, humans are the worst because of anthropogenic climate change. But if I understand correctly, for you, it's very important to acknowledge that so that we can understand the responsibility. So I was wondering whether you could just talk a bit more about like how, as you said, like the communication of those ideas is so important to understand the responsibility, and how approaching those scalar questions through this lens of intellectual history helps us conceptualize our agency and our responsibility.
Yeah. So I think it's important to, because, you know, take the kind of eternalist resignation or like nonchalance or like, you know, paralysis even sometimes. I think that that's like unquestionably for me not the right path to be taking or attitude. But then there's, you know, that as like a kind of lack of a possibly malignant lack of kind of a sense of responsibility, which doesn't have to be connected to agency per se, because obviously agency is like radically unevenly distributed. But that's like the kind of, you know, the kind of deficit of like that sense. But like you can definitely be overly you know, kind of overly have like an over kind of like hypertrophied sense of responsibility for like the whole of everything and stuff like that, which also has problems. Again, can be paralyzing. So yeah, I mean, this kind of idea that like humans are bad because of anthropogenic climate change, you know, again, obviously the responsibility for that is like radically unevenly distributed. Like, you know, we're all familiar with that. I mean, a deeper thing is that like other life forms have like caused climate change that's caused mass extinctions before. So, you know, Benjamin mentioned it in his talk yesterday, the kind of oxygenation event, where, yeah, stromatolites, which are basically just like mounds of cyanobacteria, evolved photosynthesis and then just like oxygenated the whole atmosphere, which like maybe killed like, you know, most of the bacterial life on Earth at the time, which was most life on Earth. Well, I think all life on Earth at the time. So other life forms have done these things. They've wrought those same consequences, but like we're the first life form that's like acknowledged those consequences self-reflectively and has like had any sense of responsibility for them. I think that that's interesting and something that should be held in mind when we think about the kind of cursedness or fallenness of humanity. Now, you know, saying that, like, we are destroying, like, we're leaving these deep scars and grooves in the future of the biosphere potentially. And yeah, I think that having a sense of the scale of the consequence is the place to start. So, and that requires this kind of expanded view, which, yeah, I think is, again, you know, touching on what I was saying before, we are part of this huge stream of life, and we could be a really transient and, you know, it could have been the case, you know, future perfect, that like humans are super transient in the fossil record. You know, like there have been, this is something I wrote recently, yet to be out, but about social insects, is like there have been like civilizations, aka complex societies on Earth, like since the late Cretaceous, but they're insects. Like they've proved that their societies can last for like tens of millions of years. Like we've only been around for a handful of thousand in terms of like large scale cooperative civilization. So like we're kind of untested and unproven. But like, yeah, you know, I think it's just very important to acknowledge the fact that the human species is unique in the kind of, in what it's doing. And so in terms of the fact that it's doing it and being self-reflective about it. And so yeah, I mean, I don't have an answer to the what must be done, but I think that the place to start is to acknowledge, is to deeply, and like, you know, deeply hold in mind like the position that we are in. And yeah, also on like the final point of the talk is like, you know, it's not that I love humans like massively so, it's that I think life is like awe-inspiring, that I'd want there to just be like a lot more of it in the universe. And there doesn't seem to be any good like any like knockdown arguments as to why that is impossible. So like if we could somehow like, you know, push that eventuality into actuality, sorry, that possibility into actuality, then, you know, like humans might just be the instrumental bit of like the stream of life that get like, you know, pushes it into that state where there's just far more of it. And yeah, I mean, Freeman Dyson made arguments to this kind of this kind of effect, and I find them alluring. So yeah.
No, that's perfect. Thank you so much. And yeah, my question definitely wasn't about kind of being prescriptive what we should do. I think for this whole conference, we're trying to think about mediating scale. So exactly the kind of reframing and reorienting ourselves, and in order to even be able to look for those solutions and be able to reconceptualize our condition different ways.
I mean, it makes me think, like, what's the next expansion? Like, maybe tomorrow someone will just prove modal realism, and it's like, oh wow, what is ethics now? Like that would mean that, like, every single like possibility is real. Or like, say someone just actually proves that, like, yeah, all this relativity stuff is wrong, and like the universe is open and infinite, and like, what would that mean? That means that, like, yeah, every single moment, like, the worst possible evil is happening, but at the same time, like, there are like infinite Buddhas having their like moment of nirvana. Like, what does that do to ethics then? Like, it's kind of mind-blowing. But yeah, I don't think that's going to happen anytime soon, though. So.
Just to say, but yes, thank you so much, Thomas. This was wonderful, and honestly, I couldn't be happier to have you closing the conference and really putting all of those discussions we were having throughout the 3 days in this perspective of those, huge timescales, and also spatial temporal thinking. So thank you so much for closing the conference, and for being so generous with your expertise and showing your new exciting research. And we'll be looking forward to the new book project coming to fruition. So thank you so much on behalf of me, our audience, and my co-organizer, Oliver Kenny. And before we finish, I will also bring Oliver to the floor. But once again, thank you so much, Thomas.
Yeah, thank you so much. It's not in physical space, because I just want a conversation with like all of the other panelists and keynotes. But yeah, maybe one time in the future.
That's true.
We've been saying that all along, yeah.
All along. After every talk, there's this frustration that it ends now, and then we just in your room or your office. But hopefully another time we can carry on this conversation as well. Thank you so much.
Yes, I'd just like to add my thanks to Thomas. That was an amazing presentation. Like, just so much to think about, and these connections. Yeah, it's one of the things I've really appreciated about this conference, and the way all these connections have come together. So thanks once again, Thomas, for sharing all your work with us. On a kind of sort of final note, if I may, very briefly, I just wanted to say I found this has been an amazing conference. I feel hugely inspired and humbled by all of these ideas. A few thanks. So thank you to everyone who's presented, to all of our keynotes and panelists, and to everyone who attended the presentations. Thank you also for all the questions and comments that led to some really brilliant discussions. I was very happy to be part of those. There have been lots of hugely interesting overlaps between the talks, so much potential for discussion, points of dialogue, and different perspectives. And it was great to see all, like I said, so many intertextual references being made between the presentations, and even there, like, people sort of changing their presentations slightly to fit in with what had been said before or in the discussions. On a kind of practical note, the recordings of all the keynotes will be made available in due course. Might take us a little bit of time to have a breathe after all of this, but we'll get those out to you, and we'll announce those once they're available on YouTube. Just in terms of the hosting, I'd like to reiterate my sincere thanks to the Institute of Communication Studies, the ISTC here in Lille, who hosted and financed this conference. In particular, thanks to Piero Tiocchi, Director of the Institute, and to Mehdi Gassimi, Director of Research here, for his constant support and encouragement. He came in on Saturday today to be with me, because I'm not allowed to be in the building on my own, so thanks very much to him. And then just finally, I want to give thanks to Magdalena Krysztoforska, co-organizer of the conference, who came up with the initial idea for this conference. For me, it's been an honor and a privilege to collaborate with her on this, and her expert sharing and wide-ranging knowledge and analysis throughout the conference on a personal note has been very inspiring for me. So thank you very much, Magdalena.
Thank you.
So on that note, I think we'll call it a night. It's been great. Thanks once again, Thomas, and to everyone who's still here. Good night.
Thank you. Take care, everyone.